All right, so last time we talked a lot about the value, especially it's tricky to see the value of the derivative. But you can see from this that the derivative is almost always positive, just one point where it's 0.
Yeah.
All right, so let's start trying to draw. Let's see what we can do here.
Well, it seems like the slope kind of start out small, and then
It's not going to look that steep. It's only a steepness of 1 here.
so it won't get steep that fast.
Okay.
Gradually.
All right.
So right there, it'll have a slope of 1.
Very good.
And then, I guess at 2, it's going to have to be increase with it to have a slope of 2.
Okay.
And then it's going to have to increase. It's too steep. Oh, it's going to have to increase.
It doesn't have to be perfect. But go ahead.
And then it's going to have to increase more and get a slope of 3. And then it'll have to keep increasing and increasing.
Okay, very good. Wow, nicely done.
And then the same thing over here. Or what? It is sort of the same thing. But is this side going to be negative and going down like this? Or is it?
That's what I want you guys to figure out.
Well, so the graph of the slope at, say, -1 is 1, so this is still positive.
What is still positive?
At the point -1, the slope of this graph that we're trying to draw is 1.
Okay. So don't say it is positive. What is positive?
The slope is
The slope
positive.
is positive. Okay, good.
That means that it's just gonna be the same. This is just half of it, and you can reflect it over the y-axis. I think.
But this, if you reflect it, then the slope's going to be negative on this side.
Go ahead, draw the reflection.
So if the slope, well, that's
Okay, so now find the point x equals 1 there.
Here.
Okay, does that have a slope of 1?
no, that is a slope of -1.
Okay, so does the reflection work?
No, that's weird. So then,
If it has a slope of,
if it has a slope of 1 like that, it's gonna have to sort of follow the same shape. I think it will have to sort of curve down here. Because then the slope will still be positive if you're going down here.
All right, so let's erase this part up here. We saw that wasn't right. What was the tip-off that wasn't right?
Well,
The slope
it's
is
going in a
negative.
negative direction.
What was going in negative?
This graph and the slope was just getting more and more negative.
The slope was getting negative. Yeah.
I want it to be positive
Yeah.
at the point -1.
Right.
So the slope would have to be going this way. So it's hard to see how it would connect back to this. Would it have to?
I still think it has to go down here.
Okay. Why don't you draw what you think?
So I think it's just going to look like this part. But it's going to look something like that.
Okay.
Because like at this point, the slope is going in a positive direction.
Okay.
And at -1, the slope can still be 1. Even though it doesn't look like it here.
Okay. What about at -3?
Well, like at -3, like here, the slope is still going to be 3.
Okay. So what do you think of this graph?
Yeah, it looks right.
You like this?
Yeah.
Okay. Well, your orange sketch here is indeed correct.
Cool.
And so what do you think? Do you think there's an equation we can write down for this graph?
Probably. I mean, it sort of looks like a parabola, but half of it is flipped upside down.
Okay. Well, it turns out that's actually pretty good intuition. The orange graph is x squared over 2 if x is bigger than or equal to 0. And it's negative x squared over 2 if x is less than 0. So you're right. This half is a parabola facing up.
Half's the parabola facing down.
This half's a parabola facing down. And the derivative of this function is the absolute value.
Wow, cool.
Yeah, pretty cool. So going from the function to the derivative was actually not too hard. Right, you guys just determined that discontinuous line. Going from the derivative to the function is a little harder. That is a kind of problem that I don't think either one of you has ever seen before.
No.
So it's very challenging because you have to think backwards. You have to think, okay, my slope is positive. Even though the derivative itself is decreasing, the slope is always positive. That means it has to be rising. So that function has to be negative over here. It rises, and then it rises less and less, and then at 0, it's actually flat. And then it goes up the other way.
Cool.
Cool. All right. Good work, guys.